Hello students, so we'll look into arrays today. Now before going to arrays, let us see why do we need array. So for that, let us see we have to write a program in which we have to read some 7 numbers from the user and display those 7 numbers back to the user. So we will read 7 numbers and print 7 numbers. Now to write this program, we write anyways hash include stdio.h. So we include the header file, we write main, and then this is important. So we see that we are declaring some variables. So we have to read 7 numbers. So we have declared some 7 different variables a b c d e f g. Now next thing is I write a printf statement. I ask the user to enter 7 numbers. I write percentage %d 7 times. I write these all variables here, all 7 variables with address operator. Next I write a printf in which again I have those percentage %d 7 times and the list of those 7 variables. Now this is a program for reading 7 numbers and printing those 7 numbers back on the screen. Now this is not the correct solution, or uh, say if the problem definition changes from 7 to 70 numbers. Now is it fine if we declare, or is it practical to declare 70 variables, or if it is changed to 700, so is it practical to declare 700 different variables? No, right? So that's what this is what uh, this is why we need arrays. Okay, so drawback in this program is what? We have to take 7 variables. So the solution to this problem is we can simply use array. Yes, so the answer is we can use arrays. Now what is an array? Array is a name given to set of memory location, meaning a group of elements that share a common name is the definition of array. Group of different memory locations. So you can see here, instead of 7 different variables, I have declared just one variable whose name is a, and I have told that there should be 7 locations reserved in it, meaning the size of the array is 7. Now this creates 7 different memory locations for which the memory is allocated continuously. So this is how you can visualize a of 7 array. Like we have a of 0, a of 1, a of 2 till a of 6, meaning 0 to 6 is 7 memory locations are reserved. So these 7 locations are capable of holding 7 different integers, okay, each of which will be accessed with the subscript. Now whatever I have written here in this square brackets is called as subscript or index. So the first element will be saved in index 0, the second will be saved in index 1, and so on. The size of the array, which we have given as 7 here, now this should always be an integer, meaning you cannot declare array of size 7.5 or 9.8, something like this. So here whatever we give the size, that should be integer, or to be more specific, it should be an integer constant, which means that you cannot have a variable here. Okay, you cannot say a of n or something. So this is the syntax of declaring an array. We write the data type, we give the name of the array, which is valid identifier, and then in square brackets we give the size. Okay, now this is going to create 7 memory locations like this. Let us go back to our problem definition. So what was that? To read 7 numbers and print those 7 numbers back on the screen. Now the next step would be as I discussed. So all the variables, they have the same name. So all these memory locations, 7 memory locations, they have the same name a, but then they have different indices, okay, which is 0, 1, 2, 3, and so on up to 6. They are called as indices. Now if I want to read the 7 values into these 7 variables, I write scanfs, 7 scanfs, something like this, or I can write 7 scanfs, something like this, in which I write a of 0, a of 1 till a of 6, something like this. Now still this is not the correct solution. Okay, now how do we reduce these 7 statements to 1? That let us see that. So if you observe in this scanf statements, only thing which is changing is this subscript, which is 0, 1, 2. Apart from this subscript, there is nothing else which is changing in these scanfs. Now what we have to do is we have to use some loop which is going to change the value of these subscripts. Okay, so you all have studied different types of loops. Usually for arrays we make use of for loop. It is not that we have to use compulsory for loop, you can use any loop, but usually for arrays, to read elements of an array or to print or to process the elements of an array, we use for loop. So we write a for loop which has a index variable I, which iterates from 0 to n or 0 to 6, so that we read or we access all those 6 elements or 7 elements of an array. Now this is the complete program, in which what we have done here is I have taken a for loop, as I said, to change the value of I from 0 to 7. So and I have replaced all those scanfs with these one scanf statement in which I have added. Similar process is followed for printing the element. So instead of writing printf 7 times, we see that only the index is changing here. So this index we replace by I, and we write a same for loop which in which the value of I starts from 0. It goes on incrementing every time. It becomes 1, 2, 3, 4, 5, and finally 6. After the after the 7th iteration, the value of I becomes 7. Now the condition here is 7 less than or equal to 6 is false, and this for loop is going to terminate. Now this is the simple solution, okay, using arrays. Now if you change the elements to 70, for example, user says I want to read 70 elements and print the same. Now only this will be 70. Here obviously it will be 69 and 69, and rest all is going to remain the same. Likewise, even if now I want to read 100 elements or 1000 elements, only the size of the array and here these for loops I have to change, otherwise the lines of code is going to remain same. Okay, so this is the power of arrays. Thank you. I will just continue the next discussion on the next slide.